Hello! In this video we're going to talk about asymptotes of a rational function. So what is an asymptote? It's a line that your graph is going to approach but never cross. And so basically what it means when you're looking at a graph is when you have an asymptote, your graph is going to kind of come down and it looks like it's eventually going to touch that line, but it never will. That's what an asymptote is. So in this video, we're going to talk about finding the lines in a function where your graph approaches but doesn't cross. So how do you find asymptotes? We have two different kinds. We have vertical and we have horizontal. Vertical are actually the easier of the two because you only have to remember to do one thing. To find the vertical asymptote, you take the denominator and you set it equal to 0. We do this because you can't divide by 0. That's illegal. Well, at least that's what I call it. Can't do it, not possible. So I'm going to set the denominator equal to 0 and figure out what value of x is going to make my denominator equal to 0. And that's going to be your asymptote where your line can never cross because your function will never be defined at that point. And then we're going to graph our vertical line. Remember, vertical is a line that goes straight up and down like this. And typically when you graph an asymptote, you graph it with a dashed line like this. Okay? Horizontal is where it gets a little trickier. We have three different cases of the types of horizontal asymptotes that you have, and you might think, well, that's kind of weird. It's not maybe a type, but just the scenario in which it happens. So we want to look at the degrees. Now, if you remember, when you're looking at a function, the degree is going to be your biggest exponent. So if like this would be x to the 5th and this would be x to the 4th, okay? The degrees would be 5 and 4. So we want to look at the degrees of the numerator and the denominator, and that's going to tell us how we determine what our horizontal asymptote is. So if your degree in the numerator is smaller, so the number on the top is smaller than the number on the bottom, then your asymptote is always going to be y equals 0, which is the x-axis. So it will look like when you're graphing your x-axis, you're also going to have this asymptote right on your line here like this, okay? Now, if the degree of the numerator and the denominator are the same, then you take the leading coefficient or the number out in front and you divide them, and that's going to give you what your horizontal asymptote is going to be. And then lastly, this is the one where it's tricky. If the degree of the numerator is bigger than the degree of the denominator, we don't have a horizontal asymptote. So you're like, yes, that's the easy case. But we do have what's called a slant asymptote, which is going to be just a line that's just not horizontal. So it's just going to be a slant, literally like they call it slant asymptote because it's a line something like this. And to figure out what the equation of that line is, you need to use polynomial long division. And we'll do one example of that, but not till the very end. So let's just do a couple examples to kind of get you the idea of how this works. Okay. We're not going to worry about graphing the function at this point. We're just going to graph all of our vertical and horizontal asymptotes. So to find my vertical asymptote, I'm going to write v for vertical. I'm going to set my denominator equal to 0. So 3x minus 6 is equal to 0. I'm going to draw a line down the middle. So I remember whatever I do to one side, I do to the other. I have to get x on a side by itself. So I'm going to add 6 to both sides. I get 3x equals 6 and divide both sides by 3. I'm going to zoom up here because I'm running out of space. And I'm left with x is equal to 2. So x is equal to 2, I would come in at my x is equal to 2 value, and I would draw in my asymptote like this. Now, horizontal asymptote, the degree of my numerator is 0. And the degree of my denominator is 1. So in that case, my degree is smaller, so my horizontal asymptote is going to be my x-axis, like that. Okay. Next. Okay, we're going to do vertical asymptote first, so we'll do it in blue this time. So vertical asymptote, I'm going to set my denominator equal to 0, negative x plus 5 equals 0, draw my line down the middle. I have to get x on a side by itself. I'm going to subtract 5 from both sides. So I get negative x is equal to negative 5. You can think of it two ways. If negative x equals negative 5, then positive x is equal to positive 5. Or, you have to remember this is like a negative 1. You could divide by negative 1 on both sides, and you would get positive 5. Okay, so 5, 1, 2, 3, 4, 5, we're right here, is my vertical asymptote. All right, horizontal asymptote. The degree of my numerator right here, this number is, this number is 1 and this number is 1. So the degree of my numerator is 1, the degree of my denominator is 1. So that means I have to take my leading coefficients and I divide them. So my leading coefficients are my numbers right out in front. So my number in front of my numerator is negative 1. The leading coefficient in front of my denominator is negative 1. So my final answer, negative 1 divided by negative 1 is positive 1, means that my horizontal asymptote is at y equals 1, which is right here. So it would look like this. Okay, next. Okay, vertical asymptote, we'll find it first. We're going to take our denominator and set it equal to 0. I'm going to add 8 to both sides. So I get 2x squared is equal to 8. I need to divide both sides by 2 to get x on a side by itself. And I have to take the square root. Now, when you take the square root, you have to remember you need to find all square roots. So 2 times 2 is 4, but so is negative 2 times negative 2. So this is actually giving you 2 vertical asymptotes. So you're going to have one here at 2 and at negative 2. Okay, horizontal asymptote. The degree of my numerator is 1. Remember, I'm looking here and here. The degree of my numerator is 1. The degree of my denominator is 2. So because my numerator is smaller than my denominator, y equals 0. And here we'll make it pink. Y equals 0 is going to be my asymptote or my x-axis. So here's my horizontal one, like this. Okay, next. Getting a little harder. Okay, vertical. Take my denominator, set it equal to 0. X squared minus x minus 6 is equal to 0. I'm going to factor this guy. So I want to know what multiplies to negative 6 that adds to negative 1. Now, if you have a hard time doing this, I'll do this right here. So factors of negative 6. So we have that multiply to negative 6. So positive 1 times negative 6 and negative 1 times positive 6. We have positive 2 times negative 3 and negative 2 times positive 3. Those are my only numbers that multiply to 6. Which two, when I add them together, equals negative 1? These guys. So my factors are going to be x plus 2 times x minus 3 equals 0. Then I take each one of these groups, x plus 2 and x minus 3, and set them equal to 0. So I have x plus 2 equals 0. I subtract 2 from both sides, so I get x is equal to negative 2. And then I have x minus 3 and set it equal to 0. So I add 3 to both sides and get x is equal to 3. Okay, so x is equal to negative 2 here. And x is equal to 3 here. Okay, then my horizontal, my degree in my numerator, remember we're looking up here and here. My degree in my numerator is 2. The degree of my denominator is 2, so they're the same. So that means I take my leading coefficients. So I take my number here and my number here. So y equals, the leading coefficient on the top is 2, the leading coefficient on the bottom is 1. So y equals 2 is going to be my horizontal, like this. Okay? And last, vertical. I'm going to take my denominator, I'm going to set it equal to 0. X plus 1 is equal to 0. I'm going to get x on a side by itself. So x is equal to -1. All right, so we'll graph this one. We'll make it orange. X equals -1 here. Okay, now horizontal. My degree on my top, remember we're looking here. My degree on my top is 2. My degree on the bottom is 1. So my top is greater than the bottom. So I have no horizontal, but I have a slant. But I have slant. So to figure this out, I have to do polynomial long division. So x plus 1, and inside we have a negative x squared minus 3x plus 3. Okay. X times how much is equal to negative x squared? So x times negative x is equal to negative x squared. Then I take this and I multiply it by here, and I multiply it by here. Negative x times x is negative x squared. And remember, when you do polynomial long division, when you do that first multiplying, this first term should always cancel out. And negative x times 1 is negative x. Then we add the opposite, plus, plus. So this cancels out. So I'm left with negative 3x plus x is negative 2x, and I bring down this 3. Okay, then I ask x times how much equals negative 2x? Negative 2. Negative, so then I multiply this by everything. So I do negative 2 times x and negative 2 times 1. So this gives me negative 2x and this gives me negative 2. I add the opposite and I'm left with 5. Now x times nothing is equal to 5, so this is my remainder. So in my polynomial long division, my final answer would be negative x minus 2 plus 5, all divided by x plus 1. But my slant asymptote, I'm not worried about what my remainder is. I'm only worried about here. So this is going to be the line y equals negative x minus 2. So I would graph that. So negative x minus 2. So I'm going to start at negative 2. This is like y equals mx plus b. And my slope is negative 1. So I go down 1, right 1, down 1, right 1. So I'm going to continue with my slope. So the more points I draw, personally, I do a better job connecting my lines. So my slant asymptote looks like that here. So again, we have no horizontal, but we do have a slant. All right, so basically asymptotes. Vertical, always set the denominator equal to 0, and it is okay for you to have more than one vertical asymptote. If you're dealing with like a quadratic function. Horizontal asymptotes, I'm going to zoom it right back up here. Remember, you're looking for the 3 cases. 3 cases, is your degree smaller in your numerator than your denominator? Are they equal, or is your numerator degree bigger? And those are the 3 times that it's going to tell you how to determine what type of horizontal, or in sometimes cases, slant asymptote you have. Let me know if you have any questions. Good luck.